Hi everyone, welcome back to Abrar Knowledge channel. This is the third video of mine where I'm going to discuss from the book called Juran, Quality Planning for Enterprise Quality, 5th edition. So this video is all about Minitab, and especially we will be two exercises I have taken, and from hypothesis 1, page number 624 all the way to page number 627. And which we are going to discuss today. Please stay tuned till the end. You will get the information about the Minitab and also about hypothesis also as well in real-time example. And also one more thing to let you know that I will also, the material and the data set, which I have put it up in the Minitab version as well as an Excel version, both can be shareable upon your request in YouTube. So all you need to do is you just need to comment it. So when you give a comment with the ID, email ID, I can share that also as well. Let's get into the video as such. Ideally, we are going to discuss the whether the result is a null hypothesis or alternate hypothesis, and what kind of tool in hypothesis we are going to use. So that we are going to discuss in detail. So this is scenario number 1. Which is mentioned in the book called Juran, Quality Planning for Enterprise Quality, page number 624. And it says that a medical group formed a Six Sigma team to reduce the time it took for patient to see a physician. Mean days to appointment was reduced from 8.6 days to 6.2 days. Initially, the patient used to take 8.6 days. Now they're claiming that now it is taking 6.2 days. They have taken some improvement. Analyze the data provided. This is the data being provided in the book before improvement and after improvement. Does the represent a statistically significant reduction in time? So when you have that, apparently what you do, you just take the average and find out, right? So there is a better way. That's what the hypothesis comes in, right? So this is the one. I'm going to quickly show the answer, but the same thing will be dwelled in the Minitab. So this is the data set which we talked about, and there are two things. Data are normal, and there are two things. One is called null hypothesis, one is called alternate hypothesis. So what is the average? So there are 20 data set. All these are 20, and the mean value 8.6, and the second case after 6.2, and standard deviation is 2.3, standard deviation 2.09, and standard error mean is 0.5 and 0.4, right? So there is a difference between the mean, both mean 2.4, 8.6 minus 6.2 is 2.4, right? And very importantly, t value, because we are going to discuss the two mean, right? So we can do a t test, right? So 3.45 and p value is 0.001, right? And the last one, degree of freedom is 37. What is the conclusion? Reject the null hypothesis. Why we need to reject the null hypothesis? It is concluded that before improvement and after improvement, there is a difference. If we happen to get the value, p value greater than 5%, then we say that there is no difference. Before improvement and after improvement is same. In this case, since we got the p value beautiful, 0.001, it goes to show that there is a difference between before improvement and after improvement. That's what the conclusion been drawn up in the book. It says reject the null hypothesis, conclude there is a difference, significant difference in reduction days to appointment. So the team must have done a very, very good job in reducing the time. Okay, let's go to the next scenario. This is the one which we will be doing it in the Minitab. I will be explaining it. So this is the data set, and all we need to do is, since we are talking about two sample t-tests, right? Two sample, because before improvement and after improvement. So all you need to do is you need to go for two sample t-tests, and before improvement, after improvement, and this is exactly the same value. You will get it in the Minitab also as well. Like what we discussed, 8.6 mean, 6.2, and what is the difference? What is the p value? See, exactly the p value same. And degree of freedom 37, exactly the same and all. Let's talk about, we will be doing it in Minitab, no worries. So let's talk about the example number 2. This is even more interesting. A cabinet maker was experiencing keying error, right? In order placement process. And it was hypothesis that certain error were a function of the condition of the order from builder or dealer sent by fax, right? And that is type or handwritten. It is because of the type or handwritten, right? So this is the from the builder. This is the data set, handwritten, good, bad. For example, 3,698 are good, bad is 12, and this is the same way typewritten, and this is handwritten again from the dealer and type written. So this is the data they have given, right? So I will quickly show the answer, but I will be doing it in Minitab, right? So this is the data set, and it says that the p-value, they have got it 0.43. In the first cases, we got the p-value less than 5%. Now here, more than 5%. That means we need the null hypothesis of independence cannot be rejected based on the chi-square value, because this is both a discrete data. So chi-square value 4.089, and the corresponding p-value is 0.43. And that is the first case. Next case is the null hypothesis of independence cannot be rejected. And because given the chi-square is 0.026, degree of freedom is 1, corresponding p-value is 0.872, right? And this is the way we are going to do it, because we are talking about discrete data, good, bad, and all that, right? So all you need to do is you need to go to stat and table, and you need to summarize the data, and then you can take it. Exactly how it has been given in the text, you will get the same value. For example, p-value is 0.043 and p-value is 0.872. And exactly the same value you will get it. Let's do it in the Minitab. So I have already pasted the data, and this data, what we are going to do is first case number 1, where we talked about the mean days, average mean days for a patient to see a physician, right? So this is the situation. And now what we can do is, so we can put in like go to statistic, in the statistic, basic statistic, and we are going to compare 2 sample mean, right? So you can put it 2 sample mean. Have a go and click that. And I have already given the data. So on its own, maybe I will give F3. I'll do it one more time. On its own, sample 1 is before improvement, sample 2 is after improvement, and I'm going to give OK. See, exactly the same value we got it before, and this is a set value, and the p-value we got 0.001. And degree of freedom, we got 37. Exactly the same value we got it. And let's do the second one now. So this is the value I have. As you can see, that good, bad, and all that. So this one, why we have taken the t-test, because it's both a continuous data. Here, discrete data we have, good, bad, and all that. So chi-square, we need to do it. So what we need to do for chi-square, statistic, and go to table. Right? In the table, chi-square test for association. Have a go and click that, right? So in this, again, I'm going to give F3. That means it will delete off all the values. Let's do it freshly. So that I will put it like good, bad, right? This is good and bad is from the builder. So give OK. And exactly the same value we got it. And you can see here. So first and second value, and how much value, how much in percentage, and what is chi-square value, and degree of freedom, p-value, and all that. We got it, right? Exactly the same thing. Control E I'm going to give. What I'm going to give this time is I'm going to give good and bad one. So that from the dealer, right? So give OK, and exactly the same value we have got, which we saw in the PPT, right? So just to conclude, there are 2 case study we saw. This is the case study number 1. We saw from the medical group, and there is a difference between before improvement and after improvement. They must have done the improvement. That is how we proved it. Not only from the mean we got to know, we did a t-test, and then we got to find the answer. Another one, this is what we did it in the Minitab, and hypothesis, this also we did it. And we also concluded this also as well. No, the null hypothesis cannot be rejected, right? So this is what we concluded. So I hope you enjoyed this video. Please do like, share, subscribe my channel. As I said that I will be sharing this